So, having just finished chapter 8, we now move on to the miscellaneous exercise. So we're going to start by looking at number 7. A slightly different question to what we're used to. We're given the sum of the first 20 terms, and then we're given the sum of the next 20 terms. And what we actually have to find is the sum of the first 100 terms. So first of all, you should think about what information do you need to find the sum of the first 100 terms. Well, we need the first term, which we're not told. We could do with the difference, which we're also not told. And we need the number of terms, which we are told. So we're actually given very little information to begin with to be able to calculate that. So we've got two things that we don't know, but we also have two statements that we can use. So we can write ourselves a system of equations. Now, as it says sum, we can use the n over 2, 2a plus n minus 1b formula, which we can see here. And then we can substitute in things that are relevant for this. So for the first 20 terms, n would be 20. A, I don't know. N would be 20 again, and D I don't know either. So when we substitute those terms in, then we get this expression here. Now we can also divide both sides by 10 here, and end up with 2a plus 19d equals 5, and we'll see that in a second. Now the next part is slightly strange. It says the sum of the next 20 terms. So in other words, that's terms 21 through 40. Now we don't have any formulas for that, but if we combine these two together, then what actually we have is the first 40 terms. The first 20 terms and the next 20 terms gives us the first 40 terms. Also, if we add those together, 50 plus negative 50, that gives us 0, and that's actually where our second equation comes from. We look at the first 40 terms, plug in n for 40, simplify, and actually for this one also, we can divide both sides by 20, and end up with 2a plus 39d equals 0. So we have our system of equations. I did the dividing that I mentioned here, and then we can go ahead and solve this system. So you might want to pause the video at this point and see if you can solve for A and D, and use n equals 100 and see if you can actually answer that whole question for yourself. So when I do a subtraction here, I can solve for D, and I can find that D is negative 1/4. I can then plug back into the formula to find out what D is going to be. To find out what A is going to be. And A is 4.875, or 4 7/8. And then if we use all those facts together and then plug into our formula for the first 100 terms, then what we should actually find is that it comes to negative 750. Now, the first part of this question, it's actually a two-part question. The first part you should actually be able to do for yourself. You're a farmer who is just starting up, and in the first year you produce $120,000 worth of crops. And next year you make $123,200, and the year after that $126,400. What would the total value of your crop be after 30 years if this arithmetic sequence continues? So assume also that you sell all the crop as well. So first term, we're given. We're also given a number of terms here. It tells us it's going to be 30. And we can work out the difference by doing second term, take away first term. So our difference for this is 3,200. Now we're going to use the formula, so we're going to use sum to n terms equals n over 2, 2a plus n minus 1d, and then we're going to go ahead and substitute into that formula. So the sum to n terms is 30 over 2, which is 15, 2 times the first term, so 240,000, and 30 minus 1 is 29, and our difference is 3,200. Now I actually don't have a calculator with me right now, so if you work this out, it's approximately 4 million. If I remember correctly, it's like 3.99 million, so we'll say it's about 4 million. Now that part you should be able to work out perfectly okay, and that's not really the question now. The question's actually this. Unfortunately, every third year, a violent plague of locusts attacks your crops, and you have no crops to sell because they eat them all. How much do you now earn in the 30 years? So this is actually what's happening. We got our 120,000. This is how much crop we produce. And then this is how much crop we produce in the third year, but unfortunately it gets eaten. So actually we don't manage to sell anything at all. Now we worked it out on the whole 30 years, assuming that all the crop was there. So what we actually need to do is figure out how much crop we have, and then subtract how much crop gets eaten. Now luckily for us, the crop that gets eaten is also an arithmetic sequence. First term is this one here, 126,400. And the difference, well, as this happens every 3 years, and the difference is 3,200, then 3 times 3,200 would give us a difference of 9,600. Also the number of years, originally it was 30 years, we're only looking at every third year, so 30 divided by 3 is 10. And then we can do the same thing as before, work out what the sum is using our sum formula. If we plug in n for here, 10 divided by 2 is 5. 2 times 126,400 is 252,800. 10 minus 1 is 9. Times by the difference, which is 9,600. And once again, unfortunately, I don't have a calculator with me right now, so you can work out this answer. That'll tell us how much crop is actually eaten by the locusts. And then if we subtract that from our original answer of nearly 4 million, then that will actually tell us how much of the crop we actually managed to sell within the 30 years. So quite a clever question. 2 different sequences, work out the first sequence, work out the second sequence, and then subtract those 2 answers.